Hi, in this video, we're going to find a sort of complicated area using trigonometry where we've got a sector of a circle involved. Remember, sector of a circle is just like a pizza slice, a portion of a circle. Now, how we're going to deal with this kind of complicated area? Now, we want a right angled triangle, so we can use trigonometry. And can you see that because this whole thing is a kite, because those two lengths are the same, those two lengths are the same, it has a line of symmetry, so I could split it like this. Yep. And these two triangles are going to be the same. We say they're congruent. Now, there's other stuff we know as well. We also know that this angle here is a right angle. And the reason is because this is the radius of the sector. And this line here is known as a tangent of the sector because this straight line touches this circle, this sector here. So it kind of bounces off of it. That's called a tangent. And in something called circle theorems, which we explore more fully in a later skill, we see that the angle between a tangent of a circle and a radius of a circle is 90 degrees. You can see it looks like 90 degrees, and that's because it is 90 degrees. So that's 90. Also note that because these two triangles are the same, that 74 is exactly cut in half, and half of 74 is 37. So now we've got more information. We could work out, we've got this angle here, we've got this side length here. We could work out, for example, this side length here. And the reason we might want to do that is because, well, if we think about our strategy for finding this kind of green area here, we should start with the area of the whole kite and then subtract this area of this sector here. Now, to find the area of the kite, we could just find the area of one of these triangles and double it. But to find the area of the triangle, we need to use the base and the height, because remember, the area of a triangle is half times base times height, right? So let's find this length here. So we don't know what it is, so I'm going to call it x. So let's just draw this triangle out separately. We've got the x at the bottom, we've got the 5 here, and we've got that 37-degree angle. How do we use trigonometry for this? Well, this is the angle of interest. It's the angle that we know that's not the right angle. And then these are the two side lengths of interest. Now, remember, we label the two sides relative to the angle of interest. So the 5 is next to this angle. We say it's adjacent to it. Adjacent just means next to. So we label it with an A for adjacent. And the x is opposite the angle. So we label it with O for opposite. And then remember, we use our mnemonic, SOHCAHTOA, to work out which trigonometric ratio to use. So because we're involving the O and the A, O and A is here, so it's going to be tan, so it's this one here. So remember that's short for tan of the angle, theta. Theta is just a Greek letter, usually used to mean angles, is equal to O over A. So this 37 here, that's the angle of interest, the theta. And let's just substitute everything into this formula. So we've got tan of the angle, 37, is O over A, which is x over 5. And then let's just multiply both sides by 5 to give you x is 5 tan 37. So if we do that, we get 3.76777. Right, so we've got that. So we now know, if I just cross out that x, we've got that this is 3.76777. And now we can find the area of, say, this triangle here and just double it. So the area of that triangle, or the area of the whole kite, is 2 lots of, because we've got 2 of those triangles up here, haven't we? Because we've got that triangle as well. 2 times, half times base times height. That's the area of a triangle. So it's half times the base, which is the 3.76777. Multiplied by the height, which we can see is this 5 here. And if we do that, the 2.5 just cancel each other out anyway. We're going to get 18.8389. Okay, right, so the total area is 18.8389. And now we need to subtract this sector area here from the kite to leave the green area. Now, how do we find the area of the sector? Let's just draw it separately. Got this sector here. we've got the angle. Oh, no, we actually need to work out what this angle is. But if you think about it, we know that this angle here is also 90 degrees, just like this is 90. And we know the angles in a quadrilateral add up to 360 degrees. So if we just do 360, subtract 90, and then subtract the 74, that gives you 106. So this angle here is 106 degrees. So we can put that in, that's 106. And we also know the radius of the sector, it's 3.7678 will do. Now, how do we find the area of that? Well, we know how to find the area of a full circle. It is pi r squared, right? Pi times the radius squared. We'll find the area of a full circle. But what fraction of this circle do we have? Well, a whole circle, if we had a whole circle, this total angle at the centre would be 360. So we've got 106 3/60ths of a full circle, haven't we? So we do that fraction of the area of a full circle. So let's just work that out. We've got 106 over 360 times by pi times the radius squared, which is 3.7678 squared. I'm going to do that on my calculator. 106 over 360 multiplied by pi multiplied by 3.7678 squared, and that gives me 13.132. Okay, right, so that's great. We've got the area of the whole thing, the whole shape, which is this. So that's the area of that whole diagram, the whole kite, and we're subtracting this. So therefore, the green area, the shaded area, is the area of the kite, which is 18.8389, minus the area of the sector, and let's subtract those, gives me 5 and how many decimal places do I want? 1 decimal place, so it's 5.7 centimeters squared. So that is the final answer, and we are done.